back to Let's Learn Together. I am George Youssef. In the previous two programs that we worked on, we had this program that sorted an array of 10 numbers in ascending order, and the result was right here. I copied it already and put it over here. And the other program was to print any number in AX register. Right? We converted that number, whether it's 1 digit, 2, 3, 4, or 5 digits. So let me run that. I have number 2 in AX, and it prints number 2. If I was to increase this to 3 digits, our program still works, prints 2, 3, 4. And if I was to increase that to 5 digits, 2, 3, 4, 5, 6, for example, it still works. 2, 3, 4, 5, 6 printed. So what we want to do now, while this program, this other one right here on the right side, it sorts this array of numbers that we have here in ascending order. If I run this program, you will see that in our variable, if you check, the array is sorted. Okay, so what we want to do now is combine these two together, where this program will sort the numbers, then use this program to print the numbers after they are sorted, and which is what I have here. So how do we go about doing that? We'll convert this program into a macro and then call it within this program. So let's assume we have this array over here that we want to print. How are we going to do this? I could say move into AL register array 1 to load the first number in AL and then print it. For example, emulate and run is going to print number 4. And then, or I can say array 1 plus 1, which is going to print the second number, number 8. Here we go. Or I could say array 1 plus 2, which is going to print the third number, number 12. Here we go. And so on. I can go array 1, 2, 3, 4, plus, 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 all the way to the end. Or the proper way is to set a pointer. So I can set a pointer and then increment that pointer to point to the values that I want. I can say load effective address into SI array 1. Here we go. SI is pointing to array 1. Now I can move into, we'll say AL register, whatever SI is pointing to, which is number 4 at this point. Then we can call, let's call this function 1. And I'm going to name this function 1 label. So once it prints it, goes through all these instructions, prints that first number. Once it comes back, I'm going to say increment SI to point to the second number, and then loop again. Let's call this label again, which will load the next number in our array. I'll label this again here. It's going to load the next number after we incremented it right there. Increment SI is going to load the next number, which will be number 8 in AL register, and then call function 1, which will print that number. When it comes back, we're going to increment SI again, and then load the next number, loop again, which will be number 12, and then call function 1 again to print that number. When it comes back, you get the point. So how many times are we going to do this? We want to do this for 10 numbers 10 times. So we'll put a counter in CX register. I'll say move into CX register tab to do this 10 times. Every time it loops, it decrements CX. So let's run this and see what happens. Emulate and run. So it prints some numbers, but not the desired result. What happens? It prints 4, then it prints 520, 5245, some other numbers. So what happened here? Let's emulate again, and this time single step through it. So it prints the first number correctly, 4 is printed, return, it increments as I, points to number 8 now, correctly, and then loop back. Load the next number in AL, it loads number 8, but pay attention to what we have in AH, there's a leftover number 2 from where we print the first digit. We put 2 in AH, it's still there, so now it's going to print 208. What's 208? Let's go to hexadecimal. I'll type 208 equals 520. That's what it printed. Going to print 520, right? 520. So the culprit is AH is not zeroed. So we need to we'll XOR AH with AH before we start function 1. First thing actually we do with function 1 will 0 AH. So let's run it again. And this time 4, 8, 12, 31, 44, 52, 65, 79, 102, 164, and there's 52 after that. So it went beyond what we wanted to do. Okay. Let's find out why. So we have 10 in CX. This is our count. Let's run it slower till we get to so I know why. Because we have once we're done, we do it 10 times, we have to jump to end. Because there was no jump to end, so it continued downward and it processed whatever number was left over in AL register. So let's run it again. Last, okay, here you go. 164 is the last number in our array. It's printed correctly, but there are no spaces, no commas, nothing. So this is not acceptable. We have to add space or commas in between. So what we're going to do is, after it, we call function 1 to print that number. When it comes back, we're going to say call print comma space label. Okay, what does comma space label do? I have that over here, print comma space. It puts 2C, which is comma. As you can see, if I go to ASCII table, to C right there, it's comma. Comma and DL, and then print it using 2 in AH and error of 21. After that, I put 20 in DL, that's a space, and 2 is in AH already, I call interrupt 21. If I wanted to do 2 spaces, I can do interrupt 21 again. It prints 2 spaces, but in this case, I just do 1 spaces. So let's run it again. This time it prints comma and spaces after each number. We do have comma space after the last number, which does not look good. We need to eliminate that, so let's do this, find out how. I'm gonna run this a little bit slower till we get to the last number. 1. So CX is 8, 7, 6, 5, 4, 3, 2, Okay, let me go back a little bit. So 102 is printed. Let me go back a little bit before we print comma space on this last number. So it says print comma space. It puts 2C in DL register, 2 in AH, and print comma, and then puts 20 in DL, and then prints comma space, and it returns. Now we'll increment SI, loop back to load the next number, which will be 164 in AL. So 164 in AL, there it is. A4 is 164, and then call function 1 again. So after it looped, now we have one number left to process. So we're going to go ahead and print that number, 164, 1, 6, 4 is printed, and then return, it says call print comma space. So we don't want to do comma space after the last number. What we're going to do is, after it prints the last number, we want to compare CX with the number 1. So what we're saying, when you're down to the last number to be printed, do this. I'm going to say jump if equal to $sign plus 3. Well, let's assume I don't have this for now. Let me delete it for now. And let me run it again. See what happens at the end. 6, 5, 4, 3, 2, 1. So let me go back. So once we hit the loop, CX will be decremented to 1. There we go. We are about to print the last number. Call function 1. Let's do that. I'm going to run it a little bit faster. 1 is printed, 6 printed, 4 printed. I'll stop it. Okay. And then what's after that? Call print comma space. Note over here, this is the instruction that takes 3 bytes to process it. 1, 2, 3 bytes. What's after this byte? After this instruction, if I click on 11A, goes to increment SI. So increment SI is the next instruction after that, but this takes 3 bytes. The call print comma space to execute takes 3 bytes. So what I do is, once I compare it to, after we print and come back, I'll compare it to CX register, and I'll say to CX to 1, once you reach this point, jump if equal to $sign plus 3. What I'm saying is, jump 3 bytes or skip the next 3 bytes. That's what it means. $sign plus 3. $sign means skip 3 bytes, which will skip this instruction and go directly to increment SI, so we don't have to print comma space after the last number. Let me emulate and run it this time in full speed. There we go, 164 printed without comma space. So one tricky thing about this instruction is you have to know how many bytes you want to skip first. You have to be precise. And the other thing is, this does not work if you have more than one space between JE and $sign. So in other words, if I put another space trying to line up with the remaining of the instruction, like so, I've done this mistake before, it does not work. It complains, says undeclared label, jump equal $sign plus. It complains about it, doesn't like it. So you gotta have one space only between JE and the $sign. At least in EMU 8086, that's the case. Maybe other softwares, that's not the case. In fact, I'm sure that will not be the case in other software, but in EMU 8086, this is the case. You cannot have more than one space. So what we can do now is, since this is working out for us, I'm printing all the numbers in our array right there with comma spaces as desired. We can convert this into a macro, right, and use it in this program after we sort these numbers to print the numbers in our variable that we sorted. So what I'm going to do is copy the whole program and put it in a notepad. I've already done this, saved up, and let's see. What we want to do when you do a macro, at the end, you want to say end. I'm not going to put interrupt 20, I'll put end macro. Because if I put interrupt 20 over here, when you run this macro, it ends your program. So in your macro, what we're doing in our program over here is, remember, we're calling a function, right? We're calling function 1. Instead of calling function 1, we'll call macro. So when it executes this macro, if you have interrupt 20 at the end, it will end your program completely. It's not going to come out of the macro and execute the next instruction, like incrementing SI and looping back to print the next number. So I've done this already and saved it into convert hex to D, I believe. This is the one. And instead of function 1, I named it F1, call F1, jump to the end. When it jumps to the end, it's end of the macro. It exits the macro, come back here, increment SI, perform basically the instructions after we call it. So let's take this from here and put it at the end of this program. Remember, when dx is 0, it jumps to printing right there. So I'm going to paste it over here. And instead of, like I said, instead of calling function 1, this time we'll call convert hex to D. I've already saved this right there. And I'll explain in a minute what these are. Let's check if this works. So the only problem I had was I misspelled the convert. If I click on emulate now, this should work. Okay, so it sorts the numbers and it prints it. If I was to change any number over here, it will still sort them correctly and print them as long as the numbers are not bigger than 1 byte size, which is number 255. Anything under 255, I will sort them correctly and then print the results to the screen. Note that I included over here convert hex to D, INC, ink file, and everything else is working as expected. It sorts the numbers and then it prints them. There we go. So what happened is sorts the numbers, and it decrements dx. Once it gets to 0, it jumps to printing. Printing does what? Right there. Loads array1, set a pointer to our array, puts 10 in CX to do it 10 times, loads the first number in AL, and then call convert hex to decimal, which will perform whatever this program was doing. Once it comes back, check if CX is 1. If it's not, continue downward, print comma space, then increment SI, loop back to load the next number in AL, and call the macro again to print the next number. Check if CX is 1. Continue doing this 10 times. When you reach 1 in CX, then skip the next 3 bytes, which will be skip this instruction. Go directly to increment SI, hit the loop once loop reaches 0 in CX, then jump to the end. Note over here again, you cannot put interrupt 20 at the end. Check what happens by putting interrupt 20 over here. I'll say interrupt 20 edge in my macro. I'm going to save this. If I run this program now, it prints one number only because it has the interrupt 20, it ends the macro, and it ends your program as well. So I'll delete this and the macro, just leave end macro at the end. Let's save it. Now I run this. Now it prints all 10 numbers. Cool. I forgot to explain what these two lines are in my macro. Basically what this does is tells the assembler that every label name that we have in this macro, which happens to be a lot, all these are label names, F1, L1, 5 digits, and so on. They're all significant to this macro only locally. If you find another label with the same name in the program itself, treat it differently. It has nothing to do with this label. That's all it is. So if I was to comment these out, see what happens. If I click on emulate, it's going to complain duplicate declaration of end label. So basically it's complaining that there are two labels with the same name in your program because this macro gets expanded into your program, and if it sees two labels with the same name, it's going to complain. So that's why we say local and put the loop's name or any loop name or label name you have to include it. You have to say is significantly local, important local to this macro. Unfortunately, we are way past 15 minutes in this tutorial. Please don't forget to hit the like button and subscribe, and I'll be seeing you in the next video. Thank you and have a good day. Bye-bye now.